Go back to sleep. Go get sleep.
Okay. So this is all recorded now, which isn't a problem. Just I feel like it's not ethical to record people and not tell them because it's not. Okay. So this problem that we're gonna do, I'll softball you, will be you're gonna calculate the pH of a buffer solution. So you have 0.0, actually, if you want to do this problem with that buffer solution, so you're gonna have, that's not much clearer than me saying it, is it? Okay. You're gonna have
I kind of read up a
0.006 molar, 0.006 moles, excuse me. 0.006 moles of HCl added to the buffer solution, which is 300 milliliters. And in that 300 milliliter buffer is 0.250 acetic acid molar acetic acid. And 0.560 molar sodium acetate.
still within the buffer.
Yeah, so because you need a weak acid that's conjugate base, right?
0.567.
Yeah. Multiple choice. What is a buffer? Something and something. A weak acid and its conjugate base.
0.56 molar
Molar sodium acetate. So acetic acid, but with a sodium instead of a hydrogen. Right? And the pKa, I'll give you that. The pKa is 4.74.
And then it would have been
4.74.
plus X. In that case, X would have been that mystery variable of the disassociation. Given
Okay, do you have any idea what you said?
That associated, we would have some more.
You could use.
And somehow we ended up with 0.71.
So there's a relationship with pK where it's pH equals that plus the Ka expression.
You're very close. You're talking about Henderson acid. pH equals pKa plus log of the concentration of acid over the concentration of base.
Okay.
Does that sound familiar?
Yes, but we don't have values to put in that yet. Correct? Or not everything to put in.
You do. Yes, you do.
That's so weird in that too.
Why don't you write out,
The equation.
actually, just in the interest of time, I better do it. Sorry. You're doing great, but I can do it quickly because I know the answer that I did this one. So this is our equation, right? So we have the pKa, and we do have this, and we do have this, because that is this and that. Yeah, so pH equals 4.74 plus log of 0.560 over 0.250. And that comes out to 5.09. So that's our pH. And so for the first thing, we're going to have CH3COO minus plus
That's a
okay, so
negative.
it's our acid forming. So the original concentration is
Why do you have it as forward instead of breaking?
Why do I have that? Because we're adding. So we have this amount of. This is okay. This is actually what we were just doing this last time because we have this amount of base. We have this amount of base, and then we're adding an acid to it. So in this, we had an acid, and then we added this to it. But in this problem, we have this solution. So we have this amount here. So now we're adding acid, so it's going to go back to this. Makes sense? So we have 0.300 liters times 0.560 molar sodium acetate. That's going to give us 0.168 moles initially. And then over here, we're going to have 0.300 liters times 0.250 molar. And that's going to come out to 0.0750. Yeah, it's about half. That makes sense. So then you add a certain amount of acid, right? 0.006 moles. So then the change is minus 0.0060 moles. Because you're adding this, that's how much of this is going to form, right? Because this is a linear reagent. So then you get plus 0.000 moles. So then final, I should have chosen a pen to do this, it's really distracting. 0.162 moles. This is approximately 0, that's the acid. And this will be 0.0810 moles. So then you divide this by the volume, which is 0.300 liters and 0.300 liters. So then that gives you the concentration of HA, and this gives you the concentration of A minus. When you do pH, the new pH, because you're adding an acid to it, equals pKa log of A minus over is, that's going to go out to 0.540 over 0.270. Wait, that's what these are, sorry. Log of 0.540 over 0.270, which is going to come out to 5.04. And since our initial was, what was our initial? Our initial 5.09. So 5.09 minus 5.04 equals 0.05. So that's your change in pH, which is really small, which makes sense because a buffer is supposed to stop your pH from changing that much. Let's stop this from recording really quick because I think